let's get solving. Actually, Nina, would you mind? Can I see that far? Yeah, it's Nina. Will you grab the door and shut it? Thanks. Okay, so today we're just going to be solving polynomials, just solving polynomials, and we're going to be solving by either factoring or what happens when something doesn't factor. That's what we're going to learn today, some new method. Before we do that, though, we've got to have the vocabulary down or you will be confused. Because in the instructions, they tell you to do certain things, and based on their instructions, it's going to guide you in how far you have to go. So remember what the word rational means. Can be written as a whole number or fraction. I'm going to add 0 in there. Since 0 is technically 0 over 1, it's considered a rational number. Rationals are whole numbers and fractions. Roots, you're going to see the word root come up a lot. Roots are just solutions, x-intercepts, zeros. So now there's really 4 words for the same thing. If I say to you, what are the x-intercepts? I could have said, what are the solutions? I could have said, what are the roots? What are the zeros? So like these are all examples of solutions, roots, so on and so forth. So this is a whole number solution, a whole number root. This is an irrational root, true, a solution that's irrational. It still has a radical in it. It's a decimal. And then this is an imaginary root, an imaginary solution. Today, the focus is on rational roots. Think about what that means. Fraction and whole number solutions, right, everyone? Fraction and whole number solutions, rational roots. So like these are all examples of solutions that are fractions and whole numbers. All right, then they're going to ask you for real solutions. Real solutions are anything without an I. So these are all considered real solutions. This one's an irrational, but it's still real because there's no I. All right, let's make sure we've got it because like I said, it's vocabulary that gets people. Which of these solutions are considered rational? That means can be written as a fraction or whole number. Yes, 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 no. Yes, yes, no, no. Anything with a radical or I would not be called a rational root. So pretty easy. Which of these are real roots? Anything without an I is a real root. So yes, no, yes, no, yes, yes, no. All right, which ones are rational and real? They have to be rational, they have to also be real. So would this one be rational and real? No, it's irrational. Everyone with me? This one is no, it's not real. This one's rational and real. No, it's imaginary. Rational and real. Rational and real. No, it's imaginary. All right, we're going to just get right to the point here, and I will explain all of this in words here. I'm going to just verbalize to you, and it's going to make sense. So I'm going to zoom in on this. Listen, though, because it's actually kind of cool, and it's going to help this click if you're listening to what I'm saying, the details. So if I said to you, solve this, you would set it equal to 0, correct? Everyone, yeah? When you solve something, you're finding x-intercepts. X-intercepts are when y equals 0. So that's why I set it equal to 0. Then this should be your thought process. Don't write this down because it doesn't work and I'm going to erase it. You'd say, let's try factoring. Let's solve by factoring if possible because that's always the most straightforward. And that still is. If there are 4 terms we learned in 1010, the only method that we know so far is trying to group it. You group the first 2 terms, the second 2 terms, pull out the GCF of x squared, divide by x squared, divide by x squared. Left would be 2x minus 3. Keep watching. Pull out the GCF here, which is -1. Divide by -1, divide by -1. Left is 8x plus 3. If grouping works, if method grouping works, this and this will be the exact same thing. Inside the parentheses will be exactly the same. It's not. So you'd say, okay, grouping's not going to work here, unfortunately. If it did, it would be an easier problem. So then what do we do here? Well, there is a method, and we saw it last time. So there's method synthetic division. Now, last time they said to you, okay, find all the solutions, and then they gave you a hint. Do you remember they said like x equals 1? Do you guys see? And so then you're like, oh, I'll start with 1, and then you would divide it down and make it smaller. Well, this time they don't give you a hint. So the question is like, how do we do this? So listen so I can think on how to word this to you guys well. Back there, I'm just looking at you and wanting to dig my eyeballs out. So that's what I'm thinking about right now. All right, so anyways, these mathematicians started studying polynomials, and they were looking at graphs, and they were like, wow, you know what? There's not an infinite list of possible whole number and fractional solutions that are going to show up. If I said to you, take this and just start guessing and checking, wouldn't you have like 10 million whole numbers to check? Do you guys see what I'm saying? You'd just be like shooting at a nothing, you know what I mean? So there's actually not an infinite list here. So what these mathematicians discovered is it's actually a really small list of possibilities. So it's kind of incredible that they noticed this. So here's what they noticed, everyone. So they labeled this to be able to discuss to each other what they were seeing. So everybody, P is what we're going to call our constant. Okay, so P is what we're going to call our constant for no in particular reason. It's just so we can talk. So what we're going to go off to the side and do is we're going to list out anything that multiplies to be P. What multiplies to be negative 3? 1 and 3, negative 1 and 3? And also negative 3 and 1 is a possibility, right? So think about it. We don't know which one's negative and positive. So let's not list it like that. I'm going to erase that. Let's just list it like this. Things that multiply to be negative 3, I just say 3. Things that multiply to be 3 are plus and minus 1, plus and minus 3. We don't know what's plus and what's minus. So we'll just say it's either plus or minus 1 and plus and minus 3. Then what we're going to do is list out our factors of Q. Now, once again, Q has no particular significance. They just picked something to be able to talk to each other. So leading coefficient is always going to be called Q. So we're going to list out factors of the leading coefficient. So what multiplies to be 2? Plus and minus 1, plus and minus 2. Now what these mathematicians notice is polynomials will always cross at whole numbers and fractions in this very small list of P divided by Q's. All the P's divided by Q's. So let's list out our possibilities. You've got to take every P and divide it by every Q. So 1 divided by 1 is 1. 1 divided by 2 is 1/2. Let's move on to 3. 3 divided by 1 is 3. 3 divided by 2 is 3/2. So let me state this again. These mathematicians discovered if this polynomial is going to cross at a whole number solution, it's either going to be positive 1 or negative 1, positive 3 or negative 3. Those are the only possibilities. So that's actually a pretty small list of whole numbers. Do you guys agree? They also discovered if it's going to cross at a fraction, it will cross at positive 1/2 or negative 1/2, positive 3/2 or negative 3/2. So those are the only possibilities. We're not getting into a proof of how they figured this out, why it works, why it's these, because we're not getting a degree in math right now. So you don't need to know the why. If you decide to get a degree in math, there are classes you'll take where you prove all these theorems and understand the deep meaning of why they work and how the study happened and everything. But that's just not something you need to know right now. Okay, so literally now, at least, yeah, that's a lot to go off of, but it's still a lot better than an infinite number. So now literally our only choice is to say, well, which ones actually work here? Like those are the possibilities, which ones actually work? We don't have a graphing calculator, so we have no choice but to start testing by synthetic division. And what are we looking for? A remainder of 0. All right, let's just start with 1, I guess. Positive 1. Coefficients 2, negative 3, negative 8, negative 3. Double check before you move on if you're missing a 0. So degree 3, degree 2, degree 1, constant. Okay, I just need to make sure I do that because I do forget zeros. Everyone, you guys go do synthetic division and I'll do it, and then we'll check at the end if you get a remainder of 0 or not. Compare with mine. Are you getting a remainder of 0? Oh, it went away. Oops, oops. Are you guys getting a remainder of 0? I'm not either. I'm getting negative 12. It doesn't matter the number. If it's not 0, it's no. You know what I mean? So 1 was a possibility, but it's not an actual one that works. Okay, well, let's move on. I don't know, negative 1. You literally are just guessing here. Like, which ones do you want to test next? I guess I'll try negative 1. All right, coefficient 2, negative 3, negative 8, negative 3. Check back in with me once you do synthetic division. Did negative 1 end up actually working? Yeah. Has a remainder 0. So let's go make a bucket of solutions that actually ended up working. X equals negative 1. Now here's what you've got to connect the dots on, okay? So every time you find one that works, you need to write the new polynomial and see if you can finish by factoring. Why? Because factoring is foolproof. Like, it's quick, it's efficient, and that's how you can finish it off. Now, everybody listen. In this one, we started with a power of 3. We've now divided it down once, correct? Because we did synthetic division. So now would it be a power of 2? So this will be 2x squared minus 5x minus 3. It's set equal to 0. Now we're dealing with this new polynomial, which is a quadratic. Your goal is always get this down to a quadratic. Why? Because quadratics, we know how to solve. Either it factors or it doesn't. Now listen, think about this. If it does factor, by definition, if you can factor something, it's going to end up with whole number or fractional solutions. So you'd want to finish finding your whole number and fractional solutions by factoring, rather than having to test all of these. Do you guys see what I'm saying? It'd be a pain to test those all. This will just get them there. Now, think about this. What if this quadratic doesn't factor? Then we would need quadratic formula. Now, think about it. If we need quadratic formula, that means we could get solutions like, for example, 1 plus and minus root 3, which would be considered a real solution, correct? 2 real solutions, yeah? So the question is, do they want irrational solutions or do they not? Well, we got to read our instructions. Now, watch. Couldn't we also do quadratic formula and get like 2 plus or minus 3i? So the question is, do they want your imaginary solutions or do they not? It just depends on the instructions. So let's see if it does factor. Here we go. What multiplies to be a times c and adds up to be b. What multiplies to be negative 6 adds up to be negative 5. It's going to be 1 and 6. 1 plus negative 6 is negative 5. 1 times negative 6 is negative 6. Now watch, this is wrong, but I'm going to show you what students are going to do. They're going to go x plus 1 and x minus 6 equals 0. So they're going to get x equals negative 1 and x equals 6. They're then going to go to their bucket of solutions and say negative 1, and they're going to say multiplicity of 2. This is wrong, so you shouldn't be writing it down, just watching. Then x equals 6. Now, this is where they should, if they're an advanced thinker, go, crap, something went wrong here. 6 is not even in this list of possibilities. Do you guys see what I'm saying? Well, then that's not possible. Okay, well, crap, what did I do? Oh, yeah, I cannot quick factor this quadratic. Look, the leading coefficient is not a 1. So, oh, I need a long factor my quadratic. So I need to drop down 2x squared, drop down negative 3, and rewrite negative 5x as these with an x. We all know how to factor a quadratic. I'm going to put minus 6x first, plus 1x as a personal choice. We then are grouping the first 2 terms. We all know how to factor a quadratic. Pull out a 2x. Left is x minus 3. Pull out positive 1. If there's nothing to pull out, yes, there is. It's a 1. We know that at our level. We pull out positive 1, divide by 1, divide by 1. Left is x minus 3. So we pull out x minus 3. It divides out. Left is 2x plus 1. Now that we've factored it, we can find the solutions by setting them equal to 0 and then using algebra to solve. So aren't we getting x equals 3? And x equals negative 1/2. I'm going to go add that to my bucket of official solutions. It wasn't a multiplicity of 2. It was x equals 3 and x equals negative 1/2. That was in the list of possibilities, correct? So I'm like, okay, good. Well, things are looking good. So think about it. Couldn't you have done it by another method? Couldn't you have sat and tested and then figured out, oh, you would have got a remainder of 0, yeah? But that's a pain in the butt. That was way quicker. Okay, any questions on that? Let's go on to the next one. Now, they wanted the rational zeros, so that's why we needed to list all of them. They're all whole numbers and fractions. Okay, another one. This is, I promise, I've literally taught this lesson at this point. This is my 5th time teaching it. So I promise every single example is different in a way that needs to be seen. So if we're solving it, we set it equal to 0. Now I'm going to ask you guys a question. Wouldn't you agree there's 1, 2, 3, 4 terms? So would you agree that if we want to solve the solutions, we could try grouping? Yes, that's true. Could we also do P over Q? The rational root theorem. Did I even say that yet? So they call that, the P over Q thing is called the rational root theorem. Makes sense, right? Rational root theorem is P over Q. Do you guys want me to do, I'm asking, do you want me to do grouping or P over Q? Grouping? Is that what I heard? Okay, let's group the first 2 terms, the second 2 terms, pull out GCF of x squared. Left is x minus 7. Pull out a what here? Positive 1. Left is x minus 7. Oh, glory, glory, hallelujah. Look, it's the same. We're not done, but grouping did work. So we'll pull out our x minus 7. We know it divides out, leaving us with x squared plus 1. Well, cool. I mean, yeah, that's quick. We're trying to find solutions. So now we'll set x minus 7 equal to 0, x squared plus 1 equal to 0, and then we'll solve by the most appropriate method. So we're getting for this linear piece x equals 7, aren't we? Yeah? Right here is a quadratic that has ax squared plus bx plus c equals 0. It has no middle term, which means this is the one time we can take a quadratic and just solve by taking square roots. Now, mayday, mayday, wait. Do not just square root it. That's not how it works. You have to do algebra if you're going to do method solve by square roots. So first step is subtract 1. Have I made an error somewhere? Or no? Okay, just making sure. I didn't want to move on if I had. So we have x squared equals negative 1. Square root both sides. If you solve by taking square roots, don't you need a plus and minus? So x is equal to plus and minus the square root of negative 1. What is the square root of negative 1? I. So x is equal to plus and minus I. Now my question is, how many solutions should we have? 3. Don't we have 3? The question is, next question is, but wait, do they want that? Like, am I following the instructions from the test? So it says, list the possible rational roots. Well, crap, you guys chose not to do that. You guys chose grouping, so you're going to have to circle back. Find all the real rational roots. So for that part, we can adjust our answer. What would be our answer for the real and rational roots? X equals 7. Now, unfortunately, because we did grouping, we didn't list out, and the only reason I'm going to go back and do this is because they forced me to in the instructions for my test. So they want you to do P over Q and list out possibilities. So you're like, okay, real quick, I'll do that. That's actually pretty quick. P is the constant. Let's go right here and do it. Factors of 7 are plus and minus 1, plus and minus 7. P does have to be a constant. Q is, remember, the leading term's coefficient. If you look at it, it's 1. So anything that multiplies to be 1. Well, that's just 1. Aren't we doing P's divided by Q's? So 1 divided by 1 is 1. 7 divided by 1 is 7. So now I could circle that as well. I've listed out my possible rational roots. We can see, based on the fact that we solved it by factoring, that 7 was the only one that actually worked. Now, last period, they all chose, actually, to not do grouping. They chose to do synthetic division. So let me just tell you how that unfolded. We tried positive 1, and we got a remainder of not 0. We tried negative 1, we got a remainder of not 0. We got to 7, because we were doing our possibilities, we were testing them, and we got a remainder of 0. Do you guys see what I'm saying? Yes? We then said, okay, so 7. We then wrote down our new polynomial, which was x squared plus 1, which is where ours came in right here. Do you guys see what I'm saying? And then we just solved that. So it works out to get the same answer. It's just how do you want to get there? Okay, but let's do it again. Watch this one. It's unique. It's unique. Before you do any rational root theorem, before you solve by factoring, anytime you're solving, you need to set it equal to 0. So I'm personally going to subtract 5x cubed. I'm going to subtract 9x squared. Now, if you're wondering, why did you do that instead of just move the 6x to the 4th over? And that's just because with a degree in math, we avoid having a leading term that's negative because it's just inconvenient. So it's just a habit of mine to never have a leading term that's negative. Now, I need to be very clear, so I hope you're all listening. You cannot do P over Q as is. P has to be a constant. Do you guys agree? This is not a constant. Now, here's what you can't forget. Math never changes here. When you're solving, before you do any technique, P over Q is just a technique, just like factoring. You have to first do GCF. Isn't there a GCF of x squared? 6x squared minus 5x minus 9. Now, this is my thought process. If I'm being asked to solve here, do I even need P over Q? No, my goal is to get it to be quadratic and linear. Isn't this quadratic and this quadratic? Then I don't need P over Q method. I'm just going to set these equal to 0. X squared equals 0. 6x squared minus 5x minus 9 equals 0. I'm then going to solve each. We know x squared equals 0 is the same thing as x times x equals 0. So we're getting 0 twice. X equals 0, x equals 0. Right? Okay, so that's 0 with a multiplicity of 2. I'm going to write it how we properly write it in 1050. X equals 0, and it had multiplicity of 2, which makes sense because right there it was squared. Then you'd say, okay, the quadratic, let's see if it factors. A times C adds up to be B. Well, multiplies to be negative 54 and adds up to be negative 5. I personally would go to my calculator because I'm not seeing it right off. 54 divided by 2 is 27. 54 divided by 3 is 18. 54 divided by 4 is a decimal, so I'm not going to list it. 54 divided by 5 is a decimal. 54 divided by 6 is 9. And then I did 54 divided by 7, it's a decimal. 54 divided by 8, it's a decimal. 54 divided by 9 is 6. Haven't we already listed that? Which means since we've ended up back where we've already listed, we've listed all possibilities. None of them add up to be negative 5. So you got to be an advanced thinker. Should I finish or not? Well, it's all with instructions. Can't we still solve this by quadratic formula? The question is, do we need to? In the future, yeah, you might need to. It's all in, do they just want solutions, period, end of story? Or do they want a certain type of solution? Let's go back to our instructions. It wants all real and rational. Because this doesn't factor, we know our solutions will not be whole number and fractions. Do you guys agree? So we know the solutions that are going to come from this are going to have i's or radicals. So we don't need to finish this problem this time because they only wanted rational solutions. Zero's a rational solution, so we've listed it. Now, unfortunately, we're in the same boat again where, oh my gosh, they're forcing us to list out possible P over Q's. So let's practice that real quick. You're going to go to this format and you're going to ignore x squared because P is when you're at the constant. So this would be our P. This would be our Q. So now we're going to list out factors of P. So factors of P mean factors of 9. What multiplies to be 9? Plus and minus 1, plus and minus 9. Isn't 3 and 3 also a possibility? So plus and minus 3. We don't need to list it twice. Q is 6, notice. So we're listing out factors of 6, plus and minus 1, plus and minus 6, plus and minus 2, plus and minus 3. That's going to be a decently long P over Q list because you got to divide every P by every Q. Not Q over P. I had somebody last period was eavesdropping. I just happened to be eavesdropping. And the one student was asking the other student, which is a valid question, do we need to do Q's divided by P's? No. The answer is no. So 1 divided by 1 is 1. List it. 1 divided by 6 is 1/6. 1 divided by 2 is 1/2. 1 divided by 3 is 1/3. Moving on, I've already done 1, so I'm going to go, okay, 1's good. 9 divided by 1 is 9. 9 divided by 6 is 3/2. 9 divided by 2 is 9/2. This is long. 9 divided by 3 is 3. Okay, I've taken care of 9. Let's now do 3. 3 divided by 1 is 3. I've already listed 3. Don't need to list it again. 3 divided by 6 is 1/2. I've already listed it. 3 divided by 2 is 3/2. It's already listed. 3 divided by 3 is 1. It's already listed. So now we can circle this. These were the possible whole number and fractional solutions that were rational. Okay. But none of them ended up working, correct? Correct. Okay, cool. Moving on. All right, so let's do this one. It's different. It's different. Mayday, mayday. There's things that come up. So if you're like, I get it, I'm just going to zone out. There's unique things that come up. Really, this lesson's short. We're almost finished. So you would say, let's set it equal to 0. We're asked to solve. There's 1, 2, 3, 4, 5 terms. There is no method that you've learned that will allow you to group or anything. Like, you can't factor this. So we have to use method P over Q. Sorry. Factors of 8, plus and minus 1, plus and minus 8, plus and minus 2, plus and minus 4. Factors of Q, plus and minus 1, yeah? So now we know we're doing P's divided by Q's. 1 divided by 1 is 1, 8 divided by 1 is 8, 2 divided by 1 is 2. 4 divided by 1 is 4. These are the possibilities. I'm not going to circle it. In the instructions, they didn't say what are the possibilities. They just said find the solutions here. So now you're just going to start testing. Let's try positive 1, I guess. 1, negative 2, negative 7, 16, negative 8. Double check before you move on. 4, 3, 2, 1, constant. Okay, we didn't need to put in any zeros. Seems like on the test, they always seem to at least do 1 that's missing a piece, because then it kind of like screws over the A from the A- student. Okay, check with me at the end if your 1 works so that we can compare and see if we've messed up, either of us. All right, so I'm going to make my bucket of actual solutions here. X equals 1 worked, didn't it? We're getting a remainder of 0. Now listen to my thought process. So there's 2 ways we could really continue. Well, there's kind of 3 ways we could continue. So for 1, I recommend at this point, every time you find one that works, write down, and this is important to listen to, write down the new polynomial. So listen carefully. We started with a power of 4. Haven't we divided it down 1 time? Which means our new polynomial will be x cubed. So x cubed minus x squared minus 8x plus 8, it's equal to 0. Okay, let me be very clear. Do you guys see this new polynomial compared to this polynomial, yeah? So fun fact, okay, if you were to go graph both these polynomials, for sure, this just always happens with this type of problem, because we got a remainder of 0. They're different polynomials, but they would literally cross through at the exact same x-intercepts. So what's nice is you're never, ever, ever going to go back to the original polynomial and continue testing with that. Why? Because you're trying to get it smaller and smaller and smaller till it's a quadratic so that you're guaranteed to be able to finish. So you can actually use this new polynomial from here on out to test. And think about it. Now that it's x cubed, let's say we test negative 1 and it works. Won't it now be quadratic? What if you would have went back to the originals? That wouldn't have helped you. You would have known that negative 1 worked, but you wouldn't have been able to finish. Do you guys see what I'm saying? So always use the new coefficients. Now, here's another thing I'm going to ask you. Do you guys want to keep testing? If so, would you guys prefer to move on to negative 1? Sure. What about 8? Negative 8, negative 2, positive 2, 4, negative 4. Now that's an option, yes, but couldn't you also possibly try positive 1 again? Think about why. If I try positive 1 again, if it has a multiplicity of 2, the remainder will be 0 again, correct? If it only is multiplicity of 1, our remainder won't be 0. So you'll be like, oh, it actually only happened once. So there's no right or wrong answer. It's like, do you want to try 1 again since it worked, but it might not work again, or do you want to move on? Do you want to? So I'm asking you, what would you do? Just like first, intuition. Would you move on and try negative 1?
Try 1.
You would try 1 again? Yeah. Okay, I agree. And here's why. I used to not do it that way. I used to move on, and then I would test them all. And sometimes if one if one happened again, it can a lot of times naturally unfold in the answer as you go. But here's the thing. Think about it. If we test 1 again and it does work, then we now have it as a quadratic. If it doesn't work, we only wasted our time with one extra thing. Do you guys see what I'm saying? Where you could have been saving your life, because what if we test, let me tell you what would happen here. Let's say you chose to move on. You're going to test negative 1. It's not going to work. You're going to try 8. It's not going to work. Negative 8, not going to work. 2, not going to work. Negative 2, not going to work. 4, not going to work. And negative 4 is not going to work. So then you're going to go, well, then what do? Oh, I better test 1 again. 1 ends up working again. So I always recommend testing it right away again if you're going to continue by synthetic division. Now, wouldn't you agree there's 4 terms here? So should we do it by grouping instead? It's up to you guys. Let's try it. Pull out x squared, divide by x squared, divide by x squared. Left is x minus 1. Pull out negative 8. Left is x minus 1. I am not finished, but grouping did work. It's not always going to work. You're going to get to problems where at this point, you're going to say, oh, shoot, grouping didn't work. It's not that it's a big deal. You have to use synthetic division to continue. Do you guys see what I'm saying? But it does work. So pull out your x minus 1. We know it then divides out, and we're left with x squared minus 8. Anytime you get down to linear and quadratic factors, you're in really good shape because we can always finish those. Set x minus 1 equal to 0. Set x squared minus 8 equal to 0. And then we're going to solve for x. So we're adding 1. X equals 1. Oh, look at that. We already had 1. We just got it again, so it must be multiplicity of 2. We're going to take this quadratic and solve by the most appropriate method. It has no bx, so the most appropriate method is to solve by taking square roots. Do not square root it right there. You've got to use algebra. Add 8. X squared equals 8. Square root it. X is equal to plus and minus root 8. You are expected to have simplified radicals, so I go off to the side and say root 8 is 2 times 2 times 2. So I pull out a 2. 2 roots of 2 is the prettier makeover version of root 8. So we're getting x is equal to plus and minus 2 roots of 2. Now actually, wait a minute. I better read my instructions. Should I have included that answer or not? So I don't get docked for not reading instructions. Find all the real zeros. So my question is, should I keep all solutions in here or no? No. Keep all the real zeros. So let me ask again. Should I keep all of them or not? Yeah, they're all real here. Correct, everyone? There's no i's. Did it say real rational? No, it said real, period. So yes, we would keep all of these. Now, how many solutions should I have? 4. I do have 4. Look, count. 1, 2, 3, 4. What are your questions? Do you guys need me to show you? So how it would have worked out with synthetic division, or are you seeing it? You would have tried 1 again, correct? Just watch me, don't write it down, just watch. You would have tried 1 again with the new coefficients of 1, -1, -8, and 8. Watch. You would have got 0, so you just said 1 worked again. So you would have had multiplicity of 2. You would have then said, think about this. We went from a power of 3 down to a power of 2, x squared minus 8. See, and we would end up with the same answer. Do you guys see? We'd then solve by adding 8, square rooting it. So it works out either way. Okay, moving on. All right, this is the last problem of the day, and there's a reason we're doing it. So here we go. First, you need to get it set equal to 0 and go from highest power to lowest power. So subtract 3x to the 4th. Subtract 8x squared. Now this side's 0. I'm going to write 0 at the first just to be done with it. So we have a 2x to the 5th. Ding, 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 ding. Then a minus 3x to the 4th. Then a minus 8. Oh, no, that's not next. Plus 6x cubed. Minus 8x squared plus 3. This should be what you would say to yourself. Okay, I need to solve this. And there's 1, 2, 3, 4, 5 terms. So there's no method other than P over Q that I know how to do. So list out factors of P. Things that multiply to be 3 are plus and minus 1, plus and minus 3. List out factors of Q. Q is our leading terms coefficient, plus and minus 1, plus and minus 2. Divide all your P's by all your Q's. I like to rewrite my list as it's a personal choice. My brain kind of gets weirded out by that. Some teachers just leave it like that and say, so 1, 1/2, 3, 3/2, whatever floats your boat. I'm going to just rewrite mine. 1 divided by 1 is 1. 1 divided by 2 is 1/2. 3 divided by 1 is 3. 3 divided by 2 is 3/2. These are the possibilities. Let's start testing. So should we just start with positive 1? Why not? Okay. Now here is where we've got to be careful. Am I or am I not missing a 0? You're missing 0. I mean an x. Yeah. Sorry, 0x. So if you would have got that 0, you might have been able to get the very first part right, luck out, and then the whole rest of it would have been wrong. So we put a 2, a negative 3, a 6, a negative 8, then a 0, then a 3. Let's see if 1 works. We'll check back in together at the end. You'll go do synthetic division and check back in. Does x equals 1, is x equals 1 a solution or no? Yes, you're getting a remainder of 0. Okay, let's go write it. Listen to the thought process, because getting the thought process right is really going to make or break whether this goes like harder or the easy way for you. Okay, every single time you get one that works, you need to rewrite the new polynomial and see if you can finish by method factoring. We went from a power of 5, we've divided it down just one time, which means it's going to be power of 4, 2x to the 4th, minus 1x cubed plus 5x squared minus 3x minus 3, it's equal to 0. Can we factor it? 1, 2, 3, 4, 5 terms. Nope, there's no method for 5 terms factoring. Okay, then we have to continue with p over q. We do not go back to the original coefficients. We're going to use that polynomial, that new polynomial's coefficients. Why? Because then we get it down smaller again and again and again, yeah? Now I'm going to ask you, again, it's a matter of personal choice. Would you like to move on and test -1 and then test the rest of these? Or do you think it would be like, hey, why not? Let's try to see if 1 works again.
Try it again.
Okay. Now you might get a remainder of not 0. And if you don't, then you'd say 1 must have only happened one time. While we're here, we might as well check, well, is it a multiplicity of 2? So let's try 1 again. 2, -1, 5, -3, -3. Check back in with me and see if it's multiplicity of 2 or if 1 only happened one time. So it appears to me that it did happen twice. Are you getting a remainder of 0? So listen to this scenario. What if you get a remainder of not 0? Then you're going to say, oh, okay, I got to test -1 next. You know what I mean? Okay. But, and then you just go through and test. Okay. So x equals 1, multiplicity of 2. Now we just went from a power of 4. We've divided it down once. So now it's at a power of 3, 2x cubed plus 1x squared plus 6x plus 3 equals 0. Now, could we test 1 again and see if it's multiplicity of 3? Sure, we would. Like, let's say you chose to do that. That could happen. It doesn't, though. Your remainder is not 0. So now my question for you is grouping going to work here? There's 4 terms. Let's try grouping. Or do you guys want, I'm asking you, do you want to keep testing? Would you rather finish by grouping or synthetic division? Grouping. All right, let's do grouping then. Pull out a GCF of x squared. This is our last problem. I know it's filling long. 2x plus 1. Pull out GCF of positive 3. Left is 2x plus 1. If right there it wasn't the same, you'd say, okay, I got to keep testing values. And you'd move on to -1, 1/2, -1/2, and so on. So now we're like, okay, grouping did end up working. So we'll pull out 2x plus 1. Left is x squared plus 3. Now that we've got it down to linear and quadratic, we're always set to finish. Set 2x plus 1 equal to 0. Set x squared plus 3 equal to 0, and then we'll solve for x. -1 divided by 2. X equals -1/2. Subtract 3. X squared equals -3. Square root it. X is equal to plus and minus. Asking you. I roots of 3. A lot of kids will call it 3i on accident. They like have the radical disappear, but it's not disappearing. We're just pulling out an I. Root 3 is just root 3. There's not 2 of them. So my question is, should we list that or not list it? Read our instructions. Find the real solutions. So we're just going to go add x equals -1/2 to our final answer. There should be 5 solutions. There was. Look, there's our 2 imaginary. 1, 2, 3, 4, 5. So we're like, okay, we found all the solutions. They just didn't want me to list the imaginary ones. So think of the scenario if you would have chose to not finish by grouping. When you got to -1/2, it would have worked, right? You would have had a remainder of 0, and then you would have said, oh, now I have a quadratic, so I'll finish. Okay, that's the end of the lesson. Hopefully that was pretty clear to everyone that P over Q, the rational root theorem, is just a new method to solving. A new method to factoring, if you will. Yes.
So say at the end, instead of getting the negative square root of 3,
Huh?
if we got the negative square root of 4 and it became 2i, is that a rational solution because it's a whole number, or does the I make it not?
Anytime it's I, they don't call it rational. They just, it's like it's, imaginary is its own special, like, thing. They don't even call it rational or irrational. It's just, it's imaginary.
Okay.
Yeah, good question. All right.